What I'm doing here is the shear stress distribution for I section, the same thing that we solved in the class. So it's an I section 190 mm wide and 500 mm deep. The flanges are 25 mm thick and the web is 15 mm thick. The shear force given to us in the problem is 400 kilonewton, and the moment of inertia is 6.45 into 10 raised to 8. So the first thing to do is find the maximum shear stress point, which is the most easiest in this problem, which is, so you just basically write the formula SA y bar divided by IB. So since this is given to us 400 kilonewton and this is A into y bar, so we are taking the area, the yellow thing hatched here and the green, so that's the part that we have taken here. So 190 into 25, that's the flange part, into 237.5, that is 225 plus half of this, which is 12.5. So that's that area, the flange. That's one thing. And the second part is 200 in the web, the green part, which is the 225 into 15, that's the area. And the y bar of that area is going to be 112.5, which is the half of 225 here, divided by I into B. So I, which is the given value, 6.45 into 10 raised to 8 into 15. 15 is the width of the web. So that calculating will give us 62.35 Newton per mm square. So that is the maximum shear stress which lies on the neutral axis here. The next is finding Q1. Q1 is the shear stress under this flange here, under this point. So for that we use the same formula, but what will change is of course the area, the y bar, and B. So here 400 kilonewton into 190 into 25, that is the area of the flange, 190 into 25, and of course the y bar, which is 225 plus 12.5, the half of 25. So that is this area here. So that gives us 237.5 divided by I into B. B happens to be 190 here. So solving that gives us 3.68 Newton per mm square. Now the next is finding out Q2. Now Q2 happens to be the point which is in between the flange and which is this point here. This point here. Yeah. So that gives us the area happens to be the same. So 190 into 25 into 337.5, which is the y bar of that flange area. What is different here is this B, which is 15. Solving this number will give us 46.61. So now this gives us three values. One is the Q1, Q2, and the maximum shear stress point. Now the important part is to solve the make the shear stress distribution. So this is the I section. Obviously at the extreme fibers the shear stress is 0, so this is 0. This is a parabolic curve, this one here. That gives us 3.68, which we solve for, Q2, which is 46.61, and the maximum is Q3 here, or Q max. I should write Q max, 62.35. Thank you.